Hi, students. In this lecture, I am going to discuss problems based on LC oscillations and time varying magnetic field. Let us see first one. See the question given. The capacitor of capacitance C can be charged by a voltage source V by closing switch S1 while keeping switch S2 open. The capacitor can be connected in series with an inductor by closing switch S2 and opening S1. Answer the question given. Initially, the capacitor was uncharged. Now, switch S1 is closed and S2 is kept open. If time constant of the circuit is tau, then let us see how to start. Let first of all make the given diagram. So it is given now. It is a battery. So taking a battery. Let me take this. Low potential and high potential. It is V. Resistance given R connected to capacitor. Capacitance is C. And given switch it is S1. S1. And here connected to one inductor through other switch S2. Right. Now see the first question. Capacitor was initially uncharged. Switch S1. S1 is closed and S2 open. That means it becomes now RC circuit, right? And this is growth of, it is growth of, you can say, charging of capacitor, right? Then see what is given options here. After time interval T, charge on capacitor is coming to RC circuit. Charge on capacitor as a function of time is given by, it is given by Q equal to Q naught into 1 minus e power T by tau. Now first option is when after time interval tau, if you take tau here, it becomes e power minus 1. So Q naught, where Q naught is CV, that is maximum charge on the capacitor. That means option A is not correct. Coming to option option B, after time interval 2 tau, if you take in the place of T 2 tau, it becomes e power minus 2. That means option B is matching. Okay. So B is correct. Next, the work done by the voltage source will be half of the heat dissipated when capacitor is fully charged. Okay. See how to verify this. If you remember earlier we have discussed, if a charge Q flows, if a charge Q flows through a battery, then work done by the battery equal to its EMF into charge. This is a charge Q which is flowing through battery. Its EMF is now V. Then W equal to, means work done by battery is equal to charge into EMF of the battery, right? So when Q charge is flowing, from low potential to high potential of the battery, means inside the battery. If if Q is positive, by battery, work done is positive. If Q is negative, by battery, work done is negative, right? Now you can see here charge, how much charge has flown through the battery. Initially capacitor was uncharged, finally charge equal to C into V, right? So this amount of a charge has flown through the battery from low potential to high potential inside the battery. Therefore, by battery work done is positive, and that is equal to CV into V. So it is now C with V square. Okay. This is work done. And you can see how much energy is stored in the capacitor. And that is equal to energy stored in the capacitor equal to, I am taking suffix C in capacitor, that is equal to half CV square. That means half of the work done by the battery is converting into, or you can say stored in the capacitor, and remaining half is lost because of the resistor. In that case, the given option, that means option C, it is not a correct one, right? The work done by voltage source will be half of the heat dissipated when capacitor is fully charged. That is wrong. Okay. Next, coming to option D. Directly we can select it is not correct because option B is correct. Okay. Right. Now see the next question. After the capacitor gets fully charged, capacitor is fully charged, S1 opened, S2 is closed, so that the inductor is connected in series with the capacitor. This is now LC oscillation set because S1 opened, S2 closed. Next, see options. At t equal to 0, energy stored in the circuit is purely in the form of magnetic energy. You can see when t equal to 0, capacitor is fully charged and no current is passing through the inductor. So we are knowing that energy stored in the inductor equal to, I am taking suffix M, and M stands for magnetic potential energy. It is equal to half Li square, right? And in case of LC oscillations, I can write a charge on capacitor as a function of time. That is Q equal to Q naught cos omega t. See why I have taken cos function here? Because when t equal to 0, it is open. This is open and this is closed. That means at that time, capacitor fully charged. This is a plus and this is minus. That means T0 Q charge must be maximum. That's why I have taken cos function. Otherwise, we can write sin omega t plus 90. Okay, right. Now, if you differentiate this, see we get current dq by dt. That is equal to minus q naught omega sin omega t. And when time t equal to 0, current is 0. That means since current is 0, there is no potential energy stored in the inductor. That means option A is wrong. Okay. Next, coming to option B. At any time t greater than 0, current in the circuit is in the same direction. Now see carefully here. Coming to current, you can see t equal to 0, no current. If I am focusing omega t, when omega t value 0 to 180, sine function will be positive. I'm repeating. If you take omega t value 0 to pi, sine, sine function is positive. That means in half cycle, because 0 to pi means it is a half cycle. In half cycle, direction of current is not changing. It remains same. But if you are taking omega t pi to 2 pi, next to half cycle, sine value will be negative. That means during first half cycle, direction of current, or let me draw circuit here to get more clarity. If you are taking now LC oscillations, when t equal to 0, when t equal to 0, charge on the right plate positive, right? Charge on right plate positive, left plate negative. This is t equal to 0. Okay. Now see carefully. If you are taking, let us say one fourth oscillation means t by 4, one fourth oscillation. One fourth oscillation means I'm taking here in the place of omega t 90. Okay. Then see what happens. If I'm taking 90 here, then cos 90 is 0. That means charge on right plate is 0, left plate also 0, right? Okay. Now focus when t equal to t by 2. Okay. I am writing t equal to t by 2. See what happens. This is a time means when it completes a half oscillation. So t by 2 means omega t value, it is a pi. When I'm taking cos pi, it is minus 1. That means charge on right plate, it becomes now minus, and this is a plus. That, that means once again capacitor is fully charged, but polarity is now reversed. Here, plus minus, it is minus plus, right? Fully charged. And, and here what we got? In first half cycle, direction of current is not changing. You can see here positive charge flows like this. That means the current is clockwise. That means in first half cycle, current is clockwise, right? Next, if I'm taking pi to 2 pi, let me draw here 1 second circuit. So it is now what happens, cross check once. If I'm taking next 1/4, that means 3t by 4. That means omega t value 3 pi by 2, right? 3 pi by 2 means what is the value of cos omega t? It becomes once again 0. That means 0, 0. So capacitor fully charged. Now it is no charge. That means this electric potential energy completely given to inductor. See here, 0. Capacitor was fully charged. No magnetic potential energy. After 1/4 cycle, no electric potential energy. It is a completely magnetic potential energy. Next, 1/4, no magnetic potential energy. It is a completely electric potential energy. Next, 1/4, no electric potential energy, completely magnetic potential energy. And I'm taking next 1/4 cycle. Now it becomes a plus. This becomes minus. This is one cycle, right? So in one cycle, what happens is first half cycle direction of current remains the same. Next half cycle direction of current will be reversed, right? Now see option what the option given here. Option B, at any time t greater than 0, current in the circuit is in the same direction. That is wrong. Okay. Next, at t greater than 0, option C. At t greater than 0, there is no exchange of energy between inductor and capacitor. That is wrong because it is exchanging. For every one-fourth cycle, energy completely transfer from capacitor to inductor, inductor to capacitor. Right? For every one-fourth oscillation. Right? Next, coming to option D. At any time t greater than 0, ma maximum maximum instantaneous current in the circuit may be. Current is maximum. Current maximum means energy max. And maximum value how much? When this is completely given to inductor. Okay. Therefore, I am writing here half CV square. This is maximum electric potential energy. When this is completely given to inductor, that is a half L I square. This is maximum. Half cancelled. So I maximum is equal to, see how much? It is V into root C by L. That is maximum current. So option D is match. Okay, right. See next question. If the total charge stored in the LC circuit is Q naught, given total value as Q naught, okay, it is taken as capital Q naught total value. Chart on the capacitors. Then see what happens. Now I am taking this one. Just I'm changing notations. Now I am changing here. Instead of taking small q, I am taking capital Q. Then same equation Q equal to Q naught cos omega t. Now differentiate twice. Then see what we get. dq by dt. That is equal to minus omega q naught sine omega t. Next, differentiate once again. D square q by dt square is equal to minus omega square into, I'm taking directly q, okay, because it is minus omega square into q naught cos omega t. In the place of cos omega t, I'm writing, in the place of q naught cos omega t, I'm writing directly q, okay, and we are knowing that omega equal to 1 by root LC. This is what we have discussed, right? That means in this place, what I can write? This is equal to minus 1 by LC into Q. You can see which option is match. You can see here option C is matching, right? Q equal to minus LC into D square Q by dt square, right? So option C is correct. Okay. Let's see next one. Right. Next question is, it is basing on time varying magnetic field. See what is given. A uniform magnetic field exists in a cylindrical region of radius r. Consider a non-conducting ring of mass m and radius r, that is less than Kepler, having a charge q. Its center is on the axis of the cylinder. Find the angular velocity of the ring as a function of time if the strength of the magnetic field is changing with time. Initially, the ring was at rest. Okay, this is the question given. So we have to find angular velocity of the ring. Initially, ring was at rest. So first we have to focus Since initially ring was at rest, now we have to focus who is providing torque, who is providing the torque, right? So I'm making a diagram here. So having here one cylindrical region to which magnetic field is confined, right? And taking one non-conducting ring whose center is now on the axis of this cylinder. It is now like this. Let us assume field is now, it is normal to this board plane and it is now into the board. Means into the, it is in inwards. Okay. Right. Now this is given smaller and this is capital R. So first thing is that ring was at rest. Now we have to find omega as a function of time. That means there must be a torque because of which ring starts rotating. Okay, right. So we have learned that because of time varying magnetic field, electric field is induced, right? And we have seen in that electric field lines are concentric circles. That means at each and every point on the ring, direction of field is along the tangent. Okay. So here what I'm doing is I'm taking a small element on the ring, a small element on the ring. Its a charge is now dq, right? Then direction of electric field. Suppose this field is now increasing. Okay. If field strength is increasing, direction is inwards. Here electric field is because of increasing flux. Direction of electric field is in such a way that it tries to oppose the cause of its production. Since the field is inwards and that strength is increasing, flux is now increasing. So because of the induced electric field, now we can see here, what I can say is magnetic field due to induced current should be outwards. So I'm keeping thumb outwards, thumb of right hand outwards, curled fingers. Okay, that means electric field must be like this at this point. If I'm taking at this point, it must be like this. Okay, therefore, on this element, you can see force equal to dq into E. Okay, dq into E. That is a force. Because of this force, you can see torque about this axis. Distance equal to R. Therefore, torque is now force is dq into E, force, into R, that is torque. Like this, we have to take small charges on the wire and we have to integrate. That means net torque will be equal to integration of this one. Now in this, except dq remaining all are constants. So it becomes now E into Q into R. This is net torque. And this net torque is equal to I into alpha. Right? Then see what we get. In the place of E, I am writing it is R by 2 into dB by dt. Okay. Into Q into R, that is equal to I into alpha. Now ring is rotating about its own axis. So I am writing here it is mr square into alpha. Then say calculation part. R square gets cancelled. Remaining is alpha. Okay. If we assume that dB by dt is a constant, condition is if we assume that dB by dt is a constant, take it as a k, then alpha is a constant, right? So it is a K Q by 2m. Check it once. Alpha equal to kq by 2m. Alpha is a constant. Since alpha constant, I can write omega equal to alpha t, right? Like this, we can find omega as a function of time. Okay. In fact, the same question we can solve by using, see how we are calculating same thing. So here we got alpha value. After having alpha value, we have taken omega equal to omega naught plus alpha t. Omega naught 0. Initially, it was at rest, right? So we have taken omega equal to omega naught plus alpha t. Means simply using kinematics, right? Alpha t. Now, without using kinematics, we can solve like because of this torque, there is now angular impulse. It is integration of tau bar dt. There is an angular impulse because of this torque, and that value is equal to change in angular momentum, that is I omega minus 0. Initial value 0. Then say how we get it. In the place of this, see what I can write, integration of tau bar in it, that value how much? It is a constant, right? E into q into r into dt. I can take now EQR outside because it is a constant. I omega, I value mr square into omega. So I'm taking EQR outside into integration of dt. That becomes now taking limits 0 to t. It becomes now t. That is equal to mr square into omega. In the place of e, writing r by 2 into dB by dt. We have taken that as a constant. That is k. I'm writing here into q into r into t. That is equal to mr square into omega. Right? Now simplify this. So we get same answer, right? R square gets cancelled. So omega equal to kq into t by 2m. So either calculating alpha, then using kinematics, we can find omega. Otherwise, using net angular impulse is equal to change in angular momentum. So you can solve in either way, right? So I hope you got a clarity.